Now let's look at problem solving using systems of equations. Now I know everyone loves word problems, and that's exactly what these are. Now, realistically, I know a lot of times people sometimes don't like word problems, but for those of you that don't, sometimes people will say, well, when am I going to ever use math in the real world? Well, it's those people that are to blame for having so many application problems in courses. Uh, so when you hear people say, "Hey, when am I ever going to use math in the real world?" then you can say to them, "Well, hey, thanks a lot for all the word problems. I appreciate it." Okay, so example one. Now remember, the goal is going to be to set up a system of equations. So we want to set up two equations with two unknowns. Okay, and we've only been talking about linear equations, not nonlinear ones. So you're not going to have anything squared or anything in here. Okay. So this says that the sum of two numbers is 7. So I don't know what the two numbers are, but I know when I add them together, I get 7. So if we say that the first number is x and the second number is y, then I'm saying that I'm going to add them together and I'm going to get 7. So that means for my system, the first equation should be x plus y is 7, right? Because it says the sum, so that means add, right, of two numbers, so that's x and y, is 7. Okay, now let's look at the next sentence. It says if one number, so we'll choose this to be x. So one number, we'll call that x. So if one number is subtracted from the other number, okay, subtracted from means taken away from that number. So that means that if x is taken away from y, then that means that we have y and we take x from it. Okay, so with the wording, when you see subtracted from, that means that you kind of need to kind of flip the two things. Usually you would think, okay, well the first number is x, and we're going to do x minus y. No. You have to kind of flip it because it's one number is x, and it's being subtracted from the other number. So the other, we'll call that y. So we're saying that x is subtracted from y. So that means that we take x and we subtract that from y. So we have y and then we take x away from it. So that means it's got to be y minus x. And it says the result is going to be -1. Now I like in my system to have these line up. So I'm going to rewrite this. Remember, this is a positive y. So I'm going to rewrite this as -x plus y. Oops. Plus y is equal to -1. Okay. Now these are the same, right? Because all I'm doing is the negative sign is still with the x and the y is still positive. I just switched the order. Okay, so if I move that here, I'm going to put that below. Okay, so that's going to be my system, right? It's these two equations. Okay, so this is my system of equations. And so now I have to find the numbers. So I set up the system. That's the first thing that I have to do. And now I have to solve it. So here, it's already set up to where we can easily just add the equations. So let's just add them, and then the x's will cancel out. So here I'm going to use the addition method, the elimination method, because it's already set up to where I can use that easily. So if I add these, I'm going to get 0 x's and I'm going to get 2 y's. And then when I add these, I'm going to get 6. So that means if I divide by 2, that my y is going to be 3. Okay, but if y is 3, then what's x going to have to be? It looks like x is going to have to be 4, because 3 plus 4 would be 7. So if I take this, I plug it into, say, the first equation. So that means if I plug it into the first equation, then I'm going to have x plus 3 is equal to 7. So if I subtract 3 from both sides, I'm going to get x is equal to 7 minus 3. So that means that x is going to be 4. So I've got my x and my y. Okay, now let's do a check. If I take the two numbers and add them together, do I get 7? I do. Okay, I do. Now, If we just had that piece of information, there'd be lots of answers. 2 and 5 would add together to get 7. 1 and 6 would add together to get 7. 7 and 0, right? But only with these two numbers do we is it the case that if I take x and I subtract that from y, then I get -1, right? Because if I take 4 away from 3, so that means that I'm going to have only -1, because you can't take, it's got to be a negative number because we're taking more away than is there, right? It's like if you spend more than than is in your bank account, unfortunately, you have a negative value, right? It's unfortunate that's the case. Okay, so for 3, that's our solution. Okay, so those would be our numbers. And you can just, in this case, it's really an application problem. So you could say that one number, whoops, is 4. The other number is 3. Okay. Now let's look at the next problem. Okay. So in this problem it says 2 Snicker bars and 1 Power bar contain 70 grams of carbohydrates. Okay, and then 1 Snickers bar and 2 Power bars contain 35 grams of carbohydrates, and it asks us to find the total grams of carbohydrates in each item. So what we want to be thinking about is we want to set up equations that make sense. So what do I mean by that? Okay, well what I mean is that they're going to be consistent. So first, let's choose variables for these so we know what we're talking about. Let's let S equal the number of grams, because what we're looking for is we're looking for the total number of grams of carbohydrates in each item. So then that means the thing that we want to find is the number of grams of carbohydrates in Snickers bar. We want to find the number of carbohydrates of the number of grams of carbohydrates in a Power bar. So if I let S be the number of grams of carbs in a Snickers bar, well, I don't think it has the apostrophe actually. And I'm going to let P equal the number of grams of carbs in Power bars. I guess I'll say in a Snickers bar and in a Power bar. Okay. All right. So we've set up our variables. Okay. So that's the number of grams of carbs in each one. So if we think about it, we start off with 2 Snickers bars and 1 Power bar. Okay. So if I take 2, okay, I have 2 Snickers bars, right? And so that means that however many grams of carbs are in 1 Snickers bar, like there's 2 of them, so it's twice the carbs, right? So it's 2 times S, okay? So remember, this number is representing the number of bars, and this is representing the number of carbs per bar, okay? And then if I take that and if I add that to, I have 1 Power bar, okay, 1 Power bar. So that means 1, which is the number of bars, times P, because remember, P represents the number of carbs in a Power bar. So if I take those and I add those together, I get 70 grams of carbohydrates. So we should be getting, these things that we're adding together should be grams of carbohydrates. And they are, because it's 2, right? That's just a number. We're multiplying that by grams of carbohydrates, by the amount of grams of carbohydrates in a Snickers bar. We're taking 1 and we're multiplying that by the number of grams of carbohydrates in a Power bar. So we're adding together grams of carbohydrates. Grams of carbohydrates should be 70 grams of carbohydrates. Okay, so that's the first equation. And the second equation is going to be the same kind of thing. One Snickers bar, two Powers bars is 35 grams of carbohydrates. So 1s plus 2p, that's going to be 35 grams of carbohydrates. So now I've got my system all set up. All I have to do is solve it. Okay. Now, unfortunately, if I add them, it's not gonna, nothing will cancel. So I have to multiply one of them by something, at least. And in this case, I can just multiply one equation by something because this is already a 1, so I can just multiply this by, like, say, -2, and then the power bars will cancel. So, but how about I multiply s by -2? It doesn't really matter. We'll multiply p. We'll multiply this top equation. If I take this top equation, remember this is an s, not a 25. Okay, that's important. Okay, so if I take this equation and I multiply it by -2, then I'm going to get -4s minus 2p is equal to -140. Okay, now I want to take that and I want to add that to this first equation. So I'm going to rewrite the first equation below it. Okay, now when I add these, I'm going to get -3s. These go away. Okay, and when I add these, I'm going to get, I think, like -95s. No, -85s. I'm sorry, I went the wrong direction. It's going to be -105s, right? Sorry, I didn't think about that. Okay, so now if I divide both sides by -3, then my s is going to be 105 over 3. So I don't really have a calculator handy, so let's see. If I do 105 and I divide it by 3, that's going to go in there 3 times. And that's going to be 5, because that's 15. Okay, so then that's going to be 15 grams. So that means S is going to be 15 grams of carbohydrates, right? So that means in a Snickers bar we have 15 grams of carbohydrates. Now we want to find the number of grams of carbohydrates in a power bar. So we need to take that, we need to plug that into either one of these equations. So if I plug it into the second equation, say, so I have 1 times S, which is 15, plus 2 times P, which I don't know, is equal to 35. So if I plug this in, I'm going to get 15 plus 2P is equal to 35. So if I subtract 15 on both sides, you're going to get 2P is equal to 20 divided by 2, and you're going to get P is equal to 10. Okay, P is equal to 10. And so then that means that the question asked us to find the total grams of carbohydrates in each item. Now, you don't really have to show this as a system. You don't have to show it as an ordered pair. It's a good idea to check. But, I mean, what you could do is you could just write, there's 10 grams of carbs in a power bar, and then there's 15 grams of carbs in a Snickers bar. Oh, Snickers bar. Okay, and that would